Hello viewers, this is our last part of the lesson of today, and it's talking about how to rationalize the denominator. This part is actually, sometimes we talk about it as division of surds. Usually when a fraction, a surd is given in form of fraction, you know that a fraction has got a denominator and the numerator. For example, if I say A over B, this is a fraction. But in this case, we have to rationalize the denominator only and only if the denominator is a surd. That's when the rationalized denominator comes in. But when the denominator is not surd, for example, if I have surd 8 over 4, this one, the denominator has no surd here, and therefore the idea of rationalized denominator do not come in. But if I had, for example, 20 over surd 2, then in this case, because the surd here, we are seeing a surd in the denominator here, then the concept of rationalized denominator is going to be very, very important. Now, we say that rearranging the surd so that we remove the surd from the denominator part, because when you have the surd at the denominator, division of that surd to get the exact value of that thing will be hard, except that if you use a calculator, which we say you have to round off the number's tail. But if we have to just get the exact value by keeping the integrity or the accuracy of the number as a surd, then we have to make the denominator, which is a surd, a rational number. Doing this is what we call rationalizing the denominator, to make the denominator rational, because we said that surds are irrational numbers. So changing that irrational number into rational number is what we call rationalizing the denominator. Now we have three rules that are going to guide us when we are doing so. For example, the first rule deals with when the denominator is only dealing with one value of surd A. For example, if you have a fraction in the form of x, where x can be any number, divided by surd A, then for us to rational denominator, we have to get the conjugate of that denominator. The conjugate of the denominator is a number that if you multiply by this, then the surd will not be there. And that is very easy. If we know that you have to, a number that if you multiply by surd A to remove the surd itself, then that number must be surd A again. So that if you multiply this by this, you get surd A squared. And surd A squared obviously will be A. You realize that by multiplying surd A by surd A, we end up with A. That means we have rationalized, we have been able to rationalize the denominator by removing the surd out of that particular point there. So what we have to do is the conjugate, when this one is like this, is just the denominator itself. For example, if I have 1 over surd 3, the conjugate here should just be surd 3, because it is only surd 3 times surd 3 that can remove that surd from that particular case that we have. That is that. What about if we come to the second rule, talking about when the surd, now we have A plus surd B. If you have A surd plus B, the conjugate of this denominator must be a number that if you multiply this one with, it is going to ensure we remove this surd B here so that we have a rational number, and that number should be A minus surd B. The only thing we do is we have changed the sign. So if this is A plus surd B, the conjugate should be A minus surd B. The third rule talks about when the denominator as a minus, A minus surd B. If the denominator is A minus surd B, then the conjugate of the denominator must be A plus surd B that we have actually here. So we are saying that these numbers that we have to multiply with the new denominator to remove the surd, that is A in rule 1, A plus A minus surd B in example rule 2, and A plus surd B in rule 3. We call them conjugates of the denominator. So if you don't choose the right conjugate, you can't rationalize the denominator. That is something you have to remember. If you don't choose the right one, you can never remove that surd from the numerator. So let us see some examples where we'll ask you to identify the conjugate of a surd. I'll just give 3 examples. And so let's say examples. And example, the first one, identify or state, let me just state the conjugates needed to rationalize the denominators of the following. So state the conjugate needed to rationalize the denominator of the following. A is 2 divided by surd 5. So we said that in case we talk about rule 1, where we are talking about when the denominator is just one term only. So if it is surd 5, we said that for us to remove the surd from 5 so that we just have a whole number or an integer, we need to get the conjugate should be the same as the denominator, meaning that here the conjugate that we need here, the conjugate will simply be surd 5. So we are sure that if you multiply that surd 5, numerator you multiply by the same number, and the denominator you multiply by the same number, you are sure. You are not sure to remove it on the numerator. We don't care about that, but we are caring about the denominator must not be an irrational number or a surd. B, if you have 4 plus 2 surd 2 divided by 1 minus or 1 plus surd 2. So if we have this particular problem here, the conjugate, we said if you have two terms like 1 plus, this one was just one term, here in 1 plus surd 2, we just change the sign. The conjugate will be the same thing, but here will be minus. So the conjugate for this, our second example, the conjugate for our second example should just be 1 minus surd 2. So if you multiply both the numerator and the denominator by that particular conjugate, we are going to get the denominator as a rational number. What about if I give you example 3 to identify the conjugate for me, and example this C is 15 divided by 3 minus 2 surd 5. So if I have this as my denominator in this particular question, then the conjugate is going to be the same thing, but the sign here will change from negative to positive. So the conjugate for this surd will be 3 plus 2 surd 5. So viewers, you must be able, for you to do rational denominator, you must be able to first of all identify the conjugate. If you don't do that, and for any reason you identify the wrong one, then the answer will not be rationalized, or the denominator will not be a rational number. Let us now go to the questions which deals with rationalizing the denominator. And I want to first of all talk about examples that applies rule 1. So example 2 here is rationalize the denominator. Rationalize the denominators. This is example 2. Rationalize the denominator. So here I have example A. Example A is 1 over surd 3. So I know that first, I know my conjugate is going to be surd 3. So we say that if you have to rational denominator, take this conjugate, multiply it by the numerator and also the denominator. So what I'm going to do, I'm going to say 1 over surd 3. But I know I have to multiply here by the conjugate, which is surd 3, and I have to multiply here by the conjugate, which is surd 3. So if I do that, let's see what is going to happen. 1 times surd 3 is going to be surd 3 divided by surd 3 times surd 3 should be surd 9, and therefore surd 9 is 3. So we are going to have surd 3 over 3, which I can also say is the same as a third surd 3. See how that is easy. You realize that now what we have done is that the denominator here do not have a surd at all. That's what rationalizing the denominator is all about. B, if you talk about 1 divided by surd 5, if you have 1 divided by surd 5, it's almost the same as this. The conjugate is surd 5, so we multiply the numerator by surd 5 and the denominator also by surd 5. Here, surd 5. So if you multiply that, what we get, 1 times surd 5 is surd 5 divided by surd 25. and SAD 25 is 5. So we're going to get SAD 5 divided by 5. So you see again, we have removed the SAD from the denominator. That is what we call rationalizing the denominator. What about C? C, here we have a question dealing with 5 over 80. SAD 5 divided by SAD 80. So here again, what we need to do is, we know SAD 80 here, we need to first of all simplify. We have gone through that in our first lesson. So here we are going to have SAD 5. We can't simplify that further. But SAD 80 is the same as SAD 16 times 5. So we are going to have SAD 5 here divided by SAD 16 is 4, so that is 4 SAD 5. Now, this is coming more easier than I thought. If we have this particular problem here, we can solve it by either multiplying by the conjugate of the denominator, or simply cancelling, because I can simply take out this one. And then I say the answer is a quarter. What about if we go through rationalizing the denominator? Rationalizing the denominator, I will say multiply by the conjugate of the denominator. Let me start from here. This is SAD 5 over 4 SAD 5. So 4 SAD 5. So 4 SAD 5, what about if I multiply here by SAD 5 and I multiply here by SAD 5? If I do that, what I'm going to do, this is SAD 25, and this one also will be 4 SAD 25. So we know that SAD 25 is 5 over 4, SAD 25 is 5, so 4 times 5. And 5 will still go, so that you have a quarter. So if you reach there, you can simply escape that particular long process by just cancelling out to get the answer. What about if we have 12, SAD 12, that is D, SAD 12 over SAD 48. SAD 12 over SAD 48. And as usual, let us simplify. SAD 12 is the same as SAD 4 times 3 over SAD 48 is 16 times 3. So this will be 2 SAD 3 divided by 4 SAD 3. Again here, we realize that there's no need of going through rationalizing the denominator, because SAD 3 and SAD 3 can simply cancel out, and therefore finally we have a half as the answer. So viewers, there are many ways of killing a rat, and you just choose yours. As best as you can do, choose yours so that you don't get up with a problem. I want us to go to cases where now we have the new denominator is maybe a plus SAD b or a minus SAD b. So let's look at example 3. Let's look at example 3, which is still rationalize the denominator, so that we see what it brings to us. And if you are supposed to rationalize the denominator, the first question, A, is 1 over 1 plus SAD 3. So if this is what we are supposed to rationalize, the first thing we need to do is to identify the conjugate, and the conjugate is 1 minus SAD 3 based on the second rule. So we are going to say 1 times 1 minus SAD 3 in bracket over 1 plus SAD 3 into 1 minus SAD 3. We said that you take the conjugate, and the conjugate you identify as 1 minus SAD 3, you multiply the numerator by it, and also you multiply the denominator by that number. Now you realize that we can open this bracket using the long method, but I want to show you that there's no need for that, because we remember handling what we call quadratic equations or expansions, the 3 quadratic identities. The 3 quadratic identities, we said if you have a plus b squared, This one should give you a squared minus 2ab plus 2ab plus b squared. That's 1. 2, if you have a minus b squared, this should be a squared minus 2ab plus b squared. And then identity 3 was dealing with a minus b into a plus b was given by a squared minus b squared. Now, using these three quadratic identities, we realize that our A case deals with the third quadratic identity. You see here, a plus b, a minus b. So when you have to expand this, how did we get this one? Just multiply a times a squared, b times b, b squared. The sign here must be negative. So that is very direct. I'm not going to go through the long method. Using the quadratic identities that you learned in Form 3, we can be able to bring this one forth by saying 1 times 1 side 3 will just be 1 minus side 3 over 1 times 1 will be 1 minus side 3 times side 3 is side 9. So we'll say 1 minus side 3 divided by 1, side 9 is 3, so 1 minus 3, that will give us 1 minus side 3 over negative 2. Now over negative 2 we can be able to simplify further by saying 1 divided by negative 2 is negative a half, plus, because negative side 3 minus this will be plus a half side 3, if we simplify up to that level in form of a plus b side c. So viewers, you realize that the quadratic identities that we learned earlier in Form 3 is going to be very, very important to us. And if you can master them the way they are, then opening these brackets will be really a fairly easy thing. Let's look at example 2, which is 1b is 1 over 1 minus side 5. So if that's what we have, this was plus, the conjugate here should be 1 plus side 5. That's the conjugate. So we'll take 1 in bracket 1 plus side 5, which is our conjugate. Everything divided by 1 minus side 5 multiplied by its conjugate 1 plus side 5. So if you open the bracket, that will be 1 plus side 5 divided by, you realize again we have the third quadratic identity. 1 times 1 is 1 squared, which is 1, minus side 5 times side 5 is 5. I don't want to go to now doing a lot of small things. You can be able to see that because if you multiply 1 times 1, 1 squared, side 5 times side 5 is side 25. Side 25 is 5. So here we are going to have 1 minus side 5 divided by negative 4. So if you do that, we'll get negative a quarter plus 1 over 4 side 5. That is going to be our final answer if we simplify in the form of A plus B side C. Let's look at example C. Example C. And viewers, I hope you realize that this question is fairly easy. We have 1. Now let's now go to something without 1. Let's talk about 4 divided by 3 minus 2 side 5. So 4 divided by 3 minus 2 side 5. The conjugate will be 3 plus 2 side 5. So I'll say 4 into, the conjugate is 3 plus 2 side 5 divided by 3 minus 2 side 5 times its conjugate, which is 3 plus 2 side 5. So again, if you open this bracket, this is 12. 12 plus 8. 4 times 2 is 8 side 5. Everything divided by, like we said before, difference of two squares. 3 times 3 is 9. Minus 2 side 5 times 2 side 5. The question is multiply 2 by 2 is 4. Side 5 times side 5 is 5. So 4 times 5 is 20. Now, we are multiplying side 2 side 5 by 2 side 5. You multiply that by that, and then this by this. So you'll get 4 times side 25. And 4 side 25 is 5. So you're going to get 20 there. So if you have this one, you'll get 12 plus 8 surd 5 divided by negative 11. So finally we'll say this is going to be negative 12 over 11 minus 8 over 11 surd 5, if the question was asking you to express your answer in form of A plus B surd C. Let's look at this other example, which is D. We have 1 minus surd 2 divided by 3 plus surd 2. So again, there's no worry here. We do the same thing. The conjugate is 3 minus surd 2. That 3 minus 2 multiplies numerator and also multiplies the denominator. So we'll get 1 minus surd 2 times the conjugate, which is 3 minus surd 2, divided by, we again do the same, 3 plus surd 2 multiplied by the conjugate, which is 3 minus surd 2. So after we do that, we are going to open the bracket. The numerator, we really need to open it. So I'm going to say 1 into 3 minus surd 2 minus surd 2 into 3 minus surd 2. I know that the numerator dealing with it is easy. 3 times 3 is 9, minus surd 2 times surd 2, probably surd 4, which is 2. So this is 3 minus surd 2 minus 3 surd 2 plus negative times negative will be surd 4. Surd 4 is 2 divided by 7. So we'll get here 3. Let me bring 2 here. 2 plus 3 is 5 minus surd 2 minus 3 surd 2 will be minus 4 surd 2, because this is 1, negative 1, negative 3. Everything divided by 7. If you are forced to give your answer in A plus B surd C, you will see 5 over 7 minus 4 over 7 surd 2, where in this case A is 5 over 7, B is negative 4 over 7, and C is 2. So viewers, you realize that here there's no problem. There's no much difficulties here if you put your head down to understand what you are doing. Be slow, be keen, and ensure that whatever you do, you understand each step along the way. Don't rush to hit the answer. The answer will come as a result of the right working. Let's do another one here. E, 5 is 2 plus surd 5. So if you have to get the rational denominator here, first we need to ensure we get the conjugate. The right conjugate here will be 5 into 2 minus surd 5 over 2 plus surd 5 times the conjugate, which is 2 minus surd 5. So if you open this, 2 times 5 is 10 minus 5 surd 5. Very simple. Let us open the numerator. The denominator, sorry, is this 2 plus surd 5 multiplied by 2 minus surd 5, a difference of 2 squares. 2 times 2 is 4, minus surd 5 times surd 5 is 5. So we are going to have 10 minus 5 surd 5 over negative 1. So negative 1 10 divided by negative 1 is negative 10, plus 5 divided by negative 1 is plus 5 surd 5. If you express the answer in the form A plus B surd C, this is what you actually have. Now viewers, that is what we have today, but before we go far, I want us to be able to look at kind of more challenging questions, and these more challenging questions will just be not hard enough if we do what we have just done by not being rushy. So the question, let's go to example 4, which is still saying rationalize the denominator, but now I want to give you a few hints that you are going to see in your exams. So rationalize the denominator. Okay. You have a question here, 1 divided by 3 minus SAD2 squared. So you realize that this question, viewers, is not taking the approach we have seen before. It means, first of all, we have to deal with this denominator first, expand it. After we expand it, we get the result. That result is what we rationalize. So the first thing we are going to do here is to ensure that we have 1 divided by, I don't know whether we can use quadratic identity so that we solve this problem very quickly. If I have to use quadratic identities, this will be the second quadratic identity, which is a minus b squared, which I said should be a squared minus 2ab plus b squared. So let's see. A is our 3, b is our SAD2. So let's go now. A squared is 3 squared, which is 9, minus 2ab. 2 times 3 is 6. 6 times SAD2 is 6 SAD2. Viewers, we are moving very quickly, and you should see what I'm trying to do here. My A is 3, my B is SAD2. So I'm just using this one to do the way I say A is 3, which is 3 squared is 9, minus 2ab. 2 times my A is 3 is 6, times SAD2, 6 SAD2, plus SAD2 squared is the same as SAD2 times SAD2, which actually is 2 because it's SAD4, which is 2. So when I do this, 2 plus 9 is 11, so I'll get 1 over 11 minus 6 SAD2. Now viewers, once we reach there, then we can now be able to rationalize. So rationalizing the denominator, meaning we multiply this thing by the conjugate of its denominator. So we are going to say, from here we are going to multiply 11 plus 6 SAD2 over 11 minus 6 SAD2 into 11 plus 6 SAD2. That's what we have. We have seen that before. So if you open that bracket, it just be 11 plus 6 SAD2 divided by 11 times 11 is 121. Let me confirm that. Times 11, 121 minus 6 times 6 is 36. 36 times SAD4, because 6 times 6 is 36. SAD2 times SAD2 is SAD4, which is 2. So 36 times 2 is 72. So what you are going to have here is 11 plus 6 SAD2 divided by minus 72, we have 49. So we have 49. If you are told to express it the way we are doing, we can say 11 over 49 plus 6 over 49 SAD2, if you are told to express in the form of A plus B SAD-C. So we also realize that I kind of easily did something here that could have taken some space. And if you don't know how to use the quadratic identities to open this, then please go through the long method, which is simply going to be, if you have to get this one here, what do you need to do? Let's see. You simply say 3 minus SAD2 into 3 minus SAD2. Then as usual is 3 into 3 minus SAD2 minus SAD2 into 3 minus SAD2. This is the long method. 3 times 3 is 9 minus 3 times SAD2 is 3 SAD2. SAD2 times 3 is 3 SAD2. Negative SAD2 times negative SAD2 is positive SAD4. This is 9 minus SAD3. 3 minus 3 SAD2 minus 3 SAD2 is minus 6 SAD2 plus 2. And you realize this is where we were there. So this is something that is very simple for you, and I pray that you try to master the 3 quadratic identities. Is going to help you solve a problem in a much more quicker way. Now, way forward to our number 2. Okay, let's move to example B, which is here 3 divided by 5 plus add 2 squared. Just like we handled this particular case, let us see. I want to depend on the quadratic identities so much so that I don't have to do a lot of work. But I've said if you cannot handle the quadratic identities to expand, then go through the long method when you are expanding. Now this will be 3 first. I'm not rationalizing with denominator yet. I'm still expanding. This will be A is 5 and my B is at 2. So 5 squared is 25 plus 2 times A times B. 2 times A is 10 times B is 10 SAD 2 plus SAD 2 squared is 2, because SAD 2 squared is SAD 2 times SAD 2, which is SAD 4, and SAD 4 equals 2. So this will be 3 over, this is 27 plus 10 SAD 2. So once we have this particular area, then we can rationalize the denominator. The rationalizing denominator, we get the conjugate of this one, which is going to be 3 into 27 minus 10 SAD 2 over 27 plus 10 SAD 2 times 27 minus 10 SAD 2. So once we have this, 27 times 3, 3 times 27 is 81. So 81 minus 30 SAD 2, everything divided by, as we have said before, a difference of 2 squares, that is 27 squared. 27 squared is 729, 29 minus 10 SAD 2. 10 times 10 is 100. 100 times 2 is 200, because we multiply 10 by 10, then times SAD 2 by SAD 2. 10 by 10 is 100. SAD 2 by SAD 2 is 2. So 100 times 2 is that. That is 81 minus 30 SAD 2 divided by 729 minus 200 is 529. Now, you can leave my answer from there, or you can be able to break them apart so that you express in the form of A plus B SAD C. What about if you have a case like this? It is much easier. If you have a case like this, which is much easier, the case is C, which is 1 over 5 plus SAD 2 into 3 minus SAD 2. So the other one was squares, but this one we have to expand directly, which means we'll have 1 over 5 into 3 minus SAD 2 plus SAD 2 into 3 minus SAD 2. This is 1 divided by 15 minus 5 SAD 2, then plus 3 SAD 2, then minus SAD 2 times SAD 2 is SAD 4, which is 2. So this is 1 divided by 15 minus 2. 15 minus 2 is 13 minus, because negative 3, negative 5 plus 3 is minus 2 SAD 2. So if you are opening or rationalizing the denominator, we need to multiply by the conjugate, which is 13 plus 2 SAD 2 over 13 minus 2 SAD 2 into 13 plus 2 SAD 2. So again here that is 13 plus 2 SAD 2 divided by 13 times 13 is 169. 13 169 minus 2 times 2 is 4. 4 times 2 is 8, because 2 times 2, then SAD 2 times SAD 2. SAD 2 times SAD 2 is 2. 2 times 2 is 4. That is 8 there. So we'll get here 13 plus 2 sub 2 divided by 8. And like I said, I can leave my answer here. But if the question asks me to get the form in the form A plus B to sub C, then what I need to do first is to do what? What I need to do first is to break them so that it is 13 over 8 plus 2. 2 over 8. 2 over 8 is like 1 over 4. Sub 2. Then I will be able to get my answer correct. Now viewers, you realize that we have done a lot, and before I forget something here, there's something that students will always get mixed up with, and then when they get mixed up with, they end up with crisis. If you have something like 2 over 3 plus 2 sub 2 into 3 minus 2 sub 2. Now viewers, you realize that if you have this case here, you have the conjugate, because already this thing, if you multiply this by this 3 plus 2 sub 2 is a conjugate of 3 minus 2 sub 2, and 3 minus 2 sub 2 is a conjugate of 3 plus 2 sub 2. If these things are identical, the only thing is the sign is different, then that's not actually a surd at all, because if you expand, like we are going to see, 2 divided by 3 times 3 is 9, minus surd 2 times 2 is 4, times surd 2 actually is 4 times 2, which is 8. We are going to have 2 over 1, which is 2. That is quite easy, but sometimes you find students meeting such a problem in exam and then they start shivering. You have to really be keen to know that you are dealing with such a case. I check that these terms at the denominator are conjugates of the other. This one is a conjugate of the other, and the other one is a conjugate of this, meaning they are same except the signs. Then in that case, actually, you are going to take the least amount of time to deal with it. Let me finalize this lesson by bringing a relationship between surds and trigonometric ratios. Surds and trigonometric ratios. This is part of what we are going to apply next time I'm here, but for now, let us see just a quick review of what is expected of you when we talk about deriving trigonometry or deriving surds. Deriving surds from trigonometric ratios. Trigonometric ratios of common angles. These common angles, let me say they are angle 30 degrees, 45 degrees, and 60 degrees. So sometimes you will find a question given in trigonometric ratios, but they want you to give you answer in form of A plus B sub C. Then you wonder, how did angles change to become surds? Let me start with angle 60. When I'm talking about angle 60, obviously 30 will be there. So, but first of all, let me bring in 60. So angles 30 degrees and 60 degrees. And sometimes these things you could just memorize them by knowing what they are without actually sketching. But if you don't know, you can always go the way. If I want to get angles of 60, I can divide 360, or I can divide, we know the sum of angle in a triangle is 180. So 180 is the same as if I draw a equilateral triangle where this is 60 degrees, this is 60 degrees, but I can bisect the other angle so that this and this are equal, meaning here I get 30 degrees and here I also get 30. It means that I have 30, and I have 60. Now if I take this as this side to be, can be any number, 10, 100, 50, x, y, z. Let me use 1. 1 for this side. If this is bisected into 2, this must be also 1 unit. Let's say 1 centimeters. but you can just use 1 unit. So if this is isosceles equilateral triangle, this is 2, this must also be 2 centimeters. This must also be 2 centimeters. Now, if someone asks me to get the value for angle or sine 60, let me go for sine 60. The sine of 60 degrees should be, we know sine theta, let me go like that, sin theta is normally equal to opposite over hypotenuse. So sine theta is equal to opposite over hypotenuse. But now in this case, let's talk about sine 60. So sine of 60 degrees will be, sine of 60 will be opposite, 60 is here. The opposite, let me take this as right angle triangle because I'm dealing with trigonometric ratios. We have to get a right angle triangle somewhere. So this right angle triangle here, we need to get opposite over hypotenuse. But what is this opposite here? Knowing that we have this hypotenuse and we have this adjacent, we can be able to get, using Pythagoras theorem, the value of h. Let me call it h here. Or let me call it opposite, O. So if I want to get O, I'll say that O means someone confused to be 0. So let me use x to be something that is very visible for us. X squared, the sum of the squares of the two shorter sides should give us the square of the longer side. So x squared plus 1 squared should give us 2 squared, which is here. So we'll get x squared here equals to 4 minus 1, because 1 squared is 1, 2 squared is 4. So x squared here equals to 3. So x is square root of both sides, meaning x here is surd 3. You realize where the surd is coming. So our x here is surd 3. Now let's move forward here. We said that sine theta, sine 60 should be equals to opposite, which is surd 3 over 2. So we'll say surd 3 here over 2. You realize that so sine 60 degrees is surd 3 over 2. You see where surd is coming. So we are going to see in our next class how we can, therefore, a question can come with these issues. Number 2, sine 30. What about if you have sine 30 degrees? When you talk about sine 30, we have to look for the other angle. The sine 30 is here. So if you have 30 here, the opposite is 1 and the hypotenuse is 2. So really that one will not come with a surd in it. So we are going to say this is going to sine 30 is going to be opposite 1 over hypotenuse, so it's going to be a half. That is not having a surd on it, but still it's very important for you to know. 3, what about if you have, this was A, we're dealing with the sine. What about if you have dealing with sine 45? Sine 45 degrees, we have to get another angle. So let us talk about angle 45. For angle 45, you have to get another triangle to deal with it. So angle 45, we expect an isosceles triangle, which is 45 here, and this is 90. So if you have 1 here and 1 centimeter here, what should be this? If I say this is my x there as a start, we expect that this is 1 squared plus 1 squared. The square root of the sum of 1 squared plus 1 squared should give us x squared. And this is 2 equals to x squared. So x here will be, x will be surd 2. So it means that in this case the hypotenuse is surd 2. So once we know that, then sine 45, if this is our 45 degrees, sine 45, what will it be? Sine 45 is equals to opposite over hypotenuse, which is 1. Sine 45 therefore will be 1 over surd 2. You see that one also has a surd. What about if we go to B, cos? Cos theta, we know cosine of theta is equals to adjacent over hypotenuse. So if I start with 1, the cosine of 30 will be, the cosine of 30, our 30 is here. So the cosine of 30 is adjacent, which is here, over hypotenuse. So it means that the cosine of 30 is surd 3 over 2. You realize that the cosine of 30 equals to the sine of 60. Like you can see here, the cosine of 30 we have said is going to be adjacent is this line. and the hypotenuse is this line, so side 3 over 2. And usually you can convert in your calculator. If you do sine 60, you are going to say 0.8666. You try cosine of 30, 0.86666. So cosine 30 and sine 60 are always equal. 2 cos 60. Cosine of 60, this is 60. Cosine of 60 should be adjacent over hypotenuse, which is 1 over 2. So that is also very easy. You can also realize that cosine of 60 is equal to the sine of 30. What about the cosine of 45? Cos 45, if I come here, the cos of 45 is here. Adjacent over hypotenuse is going to be 1 over side 2. So 1 over side 2. Now you realize that the cosine of 45 is the same as the sine of 45. Why? Because you normally know that as one increases, the other one decreases. The sine of 0, let's see, the sine of 0 is 0. So sine will start from 0 while end at 1 down here. Let me say this is this one going up. The cos will be 0 here, but reaching 1. So 45 is the center. If you come from 0 to 90, 45 is the middle, meaning at 45, the angles for both of these things are equal. That is why cos 45 and sin 45 seems to be equal. Let's go to B, which is the tan. Tan theta, the tan of theta equals to opposite over adjacent. So opposite of adjacent, if I say 1, what are we going to get? Opposite of tan 30, tangent of 30 degrees. The tangent of 30 degrees will be, so if I have 30 here, opposite over adjacent. So the opposite is 1 over adjacent is side 3. So I'll say that is 1 over side 3. What about 2 tan 60? Tan 60 degrees. Tan 60 degrees, 60 is here. So the tan is opposite over adjacent. So it means that tan 60 will be the reciprocal of tan 30, which is 1 over side 3 over 1. So this is going to be side 3 over 1, which we can just say is side 3. So let me say side 3. I know some of the students will be asking, where did 1 go to? Tan 45, which is our final one, is going to be, we go use the other triangle. For 45, we come here. For 60 and 30, we use this triangle here. So this one you've said tan 45, tan theta is opposite over adjacent. So opposite over adjacent. So it means that tan, this one, tan 45 is 1. So we are going to say tan 45 is 1 over 1, which is simply 1. So viewers, these are some of the things we need to know for our next lesson that we are going to use when you are trying to apply the concepts of trigonometric ratios put together with the surds to be able to yield for you some results that no one would really expect. So I want people to be able to memorize or know how to be able to generate these things. 1, we have said sin 60 is at 3 over 2, sin 30 is a half, sin 45 is 1 over side 2, cos 30 is at 3 over 2, which is the same as the sine of 60. Cos 60 is a half, which is the same as the sine of 30. And cos 45, 1 over side 2 here. And then when we come to the other side, tan 30 is 1 over side 3. Tan 60 is the reciprocal of tan 30, which is side 3. And tan 45 is 1 over 1, which is simply 1. Viewers, next lesson, if you don't understand this part here, it will be very hard for us to be able to pick from there. We are going to look at a range of areas where surds can be applied and be able to be used in our day-to-day mathematical calculations. Thank you very much and welcome. Please subscribe to our channel so that we can be able to help you learn during this critical time of coronavirus. We are dedicated, and what we expect from you is just to subscribe to our channel. That's the only support we demand from you as we try to teach the society this time. Thank you very much.